Hello everyone, welcome to my channel, welcome to another video on GPR. So this particular video is designed for the beginners. Before jumping into the GPR study or investigation, 5 basic things you should know about GPR. So these topics should be discussed in a very concise manner, which will cover the basic and the necessary knowledge about GPR. And as for bonus, I kept important piece of information at the end, so keep watching till the end. I make GPR videos every week, so please subscribe to my channel for more videos. Now let's jump into the discussion. Okay, so before understanding this topic, these 5 basic things, you should have to have some knowledge about some prerequisite like electrical and the magnetic properties of matter. What do I mean by that? So you should have a knowledge about the permittivity. You should have plus conductivity. Plus you should have knowledge about the relative permeability, dielectric constant and the permeability. So I am assuming this knowledge you already have. You know what is the dielectric constant, what do you mean by relative permittivity. And second prerequisite of this class is that you should have knowledge about the EM theory. Like, what do you mean by electromagnetic wave? What do you mean by how EM propagation happen? How EM wave propagation happen? The basics you should know, and I'm assuming that you know about that, the Maxwell's equations. And you knew these things, and once you confirm this that you know this, and then you go for the actual topic. So now let's start the main discussion here. So the very first thing you should know about GPR is the basic principles of GPR. The foundation of GPR basically lies in electromagnetic theory. So what actually GPR do? GPR system basically transmit radio wave. It's a radio wave, electromagnetic wave used in radio communications. Okay, so basically GPR system transmit radio waves to the ground and it receives the reflected signal. I know in your school you have read the reflection and refraction theory in optics. I think you have read this, okay, and it also follows the same principle. Now let me tell you how GPR system works. So it basically employs the electromagnetic wave to map the boundaries between different dielectric layers. What do I mean by that? Let's assume 2 layers are there. This one is blue and this one is the yellow layers, and these 2 layers are characterized by two different dielectric properties or 2 different dielectric parameters. So in both the cases I am considering mu equals to constant. Mu means permeability, and this sigma is denoting the conductivity, and K or the kappa it's denoting dielectric constant. So sometimes we also denote dielectric constant by epsilon r, which basically gives you the idea of relative permittivity, or both are the same, or dielectric constant. Okay, so what happened here? Transmitter transmits electromagnetic wave to the ground and it will be reflected from this boundary, and these reflected signals will be recorded or will be received as the receiver portion, and it will be recorded by using some control unit that I will discuss later. Okay, so let me give you how you can understand by using GPR, how you can understand the location of a pipe or location of any subsurface features. The theory, the basic principles of GPR basically borrowed from the seismic. So like seismic, in GPR we also observe or we also consider the amplitude of the signal. We also consider the amplitude of the signal and the two-way travel time. So what do I mean by two-way travel time? So suppose this is layer 1 and this is layer 2. Transmitter is transmitting this GPR signal and it gets reflected from here. So two different time directions. One is reaching to this surf boundary, another is reflecting from this boundary. So that's why it's called two-way travel time. The direction of the signal changes, the orientation or the path of propagation of the signal changes. So it's giving you the idea of two-way. So it's called the two-way travel time. The total time taken by this. And amplitude, you know, amplitude of any wave. So the amplitude will be recorded here, and the two-way travel time will give you the idea of the layer boundary. And how these layer boundaries are defined, I have already mentioned that these layer boundaries are defined using the variation in the dielectric properties. That means the conductivity will be different for the first layer, permittivity or the relative permittivity will be different for the first layer. Second layer, let's say the conductivity is sigma 2 and permittivity is epsilon 2. So sigma 1 is not equals to sigma 2. By this way, you will have a dielectric contrast, and that dielectric contrast will be mapped by GPR. So in a single word, or in a single, not word, it's in a single sentence, if I want to say that how GPR was, then I will say that it basically delineate the boundaries between two different dielectric medium. Okay, by using electromagnetic wave. Okay, so let me give you an idea about how these things work. So in our childhood, we do these sort of experiments, we do this sort of thing that suppose there is a well and you don't know the location of the water, and suppose this is the location of the water. So generally what we do, we used to throw pebble into the well, okay, and we used to listen signal, or not the signal, we used to listen the sound, impact sound of the pebble and the water surface from coming from that position. So by listening to that sound, that thumping sound, we can easily understand what is the depth of the well, what is the depth of the water table, at what location the water table at. Is it in a shallower location, is it in a deeper location? If it's in a deeper location, then the thumping sound amplitude will be less, and the time it will take to reach to your ear will be maximum, or will be higher. If it's in a shallower location, so what will happen? It's a very common sense that amplitude will be higher, and so in this case, if you listen, then the amplitude will be higher, but the time it will take will be very less. By this similar analogy, by the same analogy, by seeing the amplitude and the time it's taking, we can understand the nature of the boundary, we can understand the layers or the layers situated on the either side of that boundary in a GPR section. Let me give you an example. This is the layer boundary between two layers, layer 1 and layer 2, and you are using a GPR to map this layer boundary. So this is your transmitter and this is your receiver. Okay, so transmitter will be sending signal, receiver will be receiving, and from there you will be getting an idea of the, so at the receiver end, what you are getting the amplitude, and you are also recording the two-way travel time, the time it takes to reach the signal from here to here via this boundary. So when you will be receiving that signal, if this is layer 1 and this is layer 2, if the layer 1 and layer 2 has a high dielectric contrast, then what will happen? The amplitude will be higher. Okay, so the amplitude will be seeing will be higher. So by seeing these, you can identify which you can understand the properties of layer 1, you can understand the properties of layer 2 by seeing this. So you can easily map. Suppose there is a water table. So the characteristics of water table is, below of which you have a saturation zone or water saturated zone, and this is the unsaturated zone. So water has a dielectric constant or relative permittivity around 81. So what GPR investigation? So water plays an important role in GPR investigation as the value is 81. So if it's unsaturated and this one is saturated, so there generally happen what? Let's say it's a dry sand and this one is the saturated sand. So there should be a difference, or there will be a difference due to the presence of water, and that difference will be mapped perfectly. That's why GPR generally used by the hydrogeologists to map water table perfectly. Okay, so I'm not discussing about this theory in details. It's a huge chapter. I'm planning to do this discussion in a separate video about the GPR principle, but in today's class I'll be only discussing on the GPR basics which you should know. So the next thing you should know about GPR is the components of GPR. So GPR has three main components: antenna, control unit, and the power supply. Now let us discuss about the antenna. So what do I mean by antenna? When I say antenna, that consists of two components. One is transmitter and another one is receiver. Okay, so transmitter, as the name suggests, transmitter transmits the signal, receiver receives that signal. And antenna could be of two types. So antenna could be of monostatic, depending on the location of transmitter and receiver. Antenna could be of two types. One is monostatic, okay, and second type would be the bistatic. So in case of monostatic antenna, we are using the transmitter and receiver. Theoretically they are co-located. So in a single place you will be considering transmitter and receiver, and this type of antennas generally are shielded antenna. Okay, and as they are shielded, they are more focused. So the signal will be emitting from that antenna will be more focused. That part will be discussed in details in the later videos I have promised. Okay, so they are all be discussing in details about these antennas. Now transmitter, which frequency they basically transmits. So GPR works in the range. The frequency of GPR, or the central frequency of GPR antennas, lies in the range of 10 megahertz to 2.6 gigahertz. Then there is a question: which antenna you should select for GPR? So watch the full video to understand that part. Okay, now for the control unit, what's the purpose of the control unit? Let me tell you briefly first, then I'll go and discuss which antenna you should select for which type of survey. Now for the control unit, what you will do, you will be having what you have in the name of control units. You might have a laptop or a integrated PC system or a integrated control unit system. So I was using the GSSI. It's a name of GPR company. So I was using GSSI's SIR 3000, and it is a compact computer, you can say. It's basically a computer which basically controls the transmitting wave frequency. Okay, so there are several parameters will be setting in that control unit to get your desired frequency, and it can also do the processing up to some extent. And when you will be receiving, the receive signal will be stored here also. So it's kind of like a computer with a memory card. So it might have an internal memory, or it has the memory card. Most of the cases I'm talking about this integrated system. Laptop, you know, everyone knows about the laptop system, but in this integrated system you will have a memory card inside of it, or it might have an internal memory. Then I was using GSSI system. There they were using the operating system Windows. Okay, so it's just like your home computer, it's just like your laptop, but it controls, it's specially designed to control or transmit the electromagnetic wave into the ground, the specified electromagnetic wave into the ground, and it will receive that signal, the reflected signal or the refracted signal. Now third most important point here is the power supply. So as for power supply, we will have some batteries. Okay, if you are using a laptop, then laptop batteries, you know about that lithium ion batteries. The control unit I have used for the GSSI, most of the equipment you will find, most of the sophisticated instrument you will find, that's the lithium ion batteries will be there. Just like any smartphone batteries, just like any old mobile batteries. So these batteries will be lithium ion batteries. You have to charge it every time, and once you charge it, you can do the survey up to suppose, depending on the frequency, again depending on the frequency you are using. So if you are using 200 megahertz monostatic antenna, so we can do the survey up to, let's say, 4 hours or more than 4 hours using that battery. So there will be some spare battery also, or you should carry some spare battery into the field for that purpose, because later what will happen, the batteries, just like our smartphone batteries, it got it getting more diluted easily. Okay, it is the capacity of holding the charge for a long time decayed easily. Okay, so you should carry some extra battery. Now let's come to the important question here: how to select an antenna for the GPR survey? Which antenna you should buy, which transmitting frequency, which antenna type you should buy. Suppose you have the control units, and remember, these things are very independent units. So control unit is your independent unit, your antenna will be the independent unit. Let's have an example like a DSLR camera. So in this DSLR camera, you have a camera body, okay, and now you can add any lens goes with that camera. So the lens you are changing, but the camera body is fixed. In this case, the control unit is fixed. Okay, so control unit will be fixed. You will be changing the antenna. So how to select an antenna for GPR survey? For the geological investigation, means, what do I mean by that? That means in coastal areas or water table mapping, you will be going for in coastal area studies, fluvial area studies, or hard rock investigation. You will be going to buy, or you will be buying the antenna with frequency, or the center frequency in between 10 megahertz to 500 maximum 500 megahertz. If you intend to do geological investigation, then you will be doing 10 megahertz to 500 megahertz, or you will purchase the set 10 megahertz frequency. So there are several options available in the market, that if you are buying some GSSI antenna, so they have 16 to 80 megahertz MLF antenna unshielded, they have 400 megahertz antenna, they have 200 megahertz shielded antenna. So those options are there. Sometimes you will have the 500 megahertz antenna. So up to 500 megahertz is used because 500 megahertz may give you the data, may give you the result up to 2 meters. Most of the cases for geological investigation. And 60 to 80, you can consider their writing, it can penetrate up to 50 meter, but in practical, let's consider a in between them. So it can go up to, or the GPR signal can go up to 35 meter. Okay. So for geological investigation, you will be using 16 to or 10 to 50 500 megahertz antennas. For civil engineering applications, okay, so 200 megahertz antennas are also used, or the 500 megahertz antennas are mainly used for the utility survey. 200 can be used also for some shallow subsurface investigation, because it will give you the depth up to 7 to 9 meter. So you can map up to 7 to 9 meter depending on the site condition. Okay, remember that. So the site condition is an important factor also to get your data. So dry condition is always preferred. That will be discussed later, or that will be discussed in a separate video. So for a utility survey, you will be using the 500 megahertz because it will go up to 2 meter depth, and it can give you the high resolution result. Okay, now for the utility survey, I have already discussed. Now for civil engineering application, they generally use the 2.6 gigahertz antenna. So how this 2.6 gigahertz antenna works? And remember one thing: if the frequency increases, you have to understand one thing: if the frequency of the system increases, then the resolution will be higher, but the depth of penetration will be lower. Okay, so 2.6 gigahertz give you very high resolution data, but it can penetrate up to few centimeter. This is generally used to understand the crack in the walls, crack in the concrete, or crack in the concrete which placed in the wall of a bridge or anywhere. Okay, any civil engineering construction. So you have to understand that 2.6 gigahertz is very high. It will give you few centimeter result, and it will give you a high resolution data. And the size of this instrument, 2.6 gigahertz, is very less. Okay, so I'll put a photograph here. So the size of 2.6 gigahertz is very less comparing to the 200 megahertz. So size of 200 megahertz antenna will be larger, or way much larger. So it could be a handheld instrument. And 200 megahertz instrument, it's portable. Obviously it's a portable, but it will be a bigger in size. So as the frequency increases, the sizes of the antenna become smaller. Present one example from GSSI. So they have what they have done. They have basically 2.6 gigahertz antenna available there, and they basically use for the concrete evaluation. 400 megahertz generally used for environmental and void detection. See from this, you can pause the video and you can note down these applications or typical applications of center frequency or several antennas. So we generally use, as a geophysicist or a geologist, we generally use 15 to, or in general case 10 to 500 megahertz antenna. So for the geological application, we generally use 10 to 500 megahertz antenna, and civil engineering, they generally use in the gigahertz range. Okay, 900 megahertz to, let's say, 900 megahertz to few gigahertz range. Next important point of GPR you should know is the applications of GPR, where you can apply GPR. So GPR has wide range of applications. So it could be in utility, it could be in civil engineering application, it could have a hydrogeophysical application, it might have a geological, archaeological, and military applications. So it's about this utility survey, and when you are doing a utility investigation, that means you can identify the pipes, you can identify the leakages. Okay, you can identify the type. Is it an electrical one? Is it a water pipe? Is it a some oil pipe? Okay, if it's located in a shallow condition, then you can easily identify the location more prominently. You can identify the type. Okay, or you can identify, or let's say some contractor made you a road, and that road you have to evaluate. How do you evaluate? You will be evaluating that road using GPR. So GPR can evaluate the pipe, its leakage, road inspection can be done using GPR. Okay, and several other shallow subsurface features or shallow subsurface anthropogenic features can be identified using GPR. Now for the geological condition, or for the geology, you can do a whole lot of work, like you can do the water table mapping, which is a part of hydrogeology also. You can do water table mapping. You can do the contaminant mapping. This is a very important one. Nowadays people are using more to identify LNAPL and DNAPL. Okay. Now you can do some sedimentary subsurface identification, sedimentary feature identification. You can do the fault. If it's in a shallow subsurface, then you can identify the fault or the fracture zone. So fault or fracture can be identified. So it has wide range of application. Some coastal setting you can identify. The evolution of coastal setting can be identified using this GPR system. Erosional surfaces can be identified using GPR system. So it's a wide range of applications, several applications. Sometimes it integrates with some other geophysical method and it gives you a good result. So nowadays people are using integrated technique to understand the subsurface better. Okay. For civil engineering application, I have already discussed that you can identify the pipe, you can evaluate the concrete. Glaciological investigation, which I would like to discuss. So GPR works very well in glacier, in ice. Why? The basic fundamental principle you should remember about GPR, that if your overburden is resistive, okay, then if this one, the overburden, the topsoil is resistive, then GPR works well. And freshwater ice is generally resistive one. So in glacier it can penetrate up to 1 kilometer. Using suitable antenna you can go up to, in general for sedimentological cases, GPR gives you the result up to, let's say up to 50 meter maximum. But in ice it can goes up to, it can see up to 1 kilometer. So it has a huge application in glaciology. Okay, people are using GPR in archaeological investigation also. So I read somewhere that most of the archaeological remains are within 5 meter from the surface. So 5 meter, if you have a high resolution imagery of that 5 meter without digging it, because you know these things are very sensitive, you have to tackle it very carefully. Now if you know at which location your artifacts remains or artifacts situated, then you can easily dig it. Okay, by going by or without going blindly, you can do a GPR survey and you can get okay, at 2 meter you have this artifact, so you can easily dug out this 2 meter location. Suppose it's a huge area, it will cost your time and effort. Okay, so GPR basically gives you a high resolution image. This is a general statement, in less time. So it's basically a cost effective technique for shallow subsurface. So it's a cost effective technique for shallow subsurface. Okay, then there are other applications are also there, like the military applications. So they generally use GPR. Sometimes you have seen the metal detectors, and people are so clever that they put landmine in such a casing that you cannot identify with the metal detector. Then you will go for the landmine detection, can be done using the GPR also. So there is a specialized equipment for that. But if you are a geologist or geophysicist, or if you are from civil, then you will be using that frequency of antenna. So for military landmine detection they use higher frequencies, and I have already discussed which frequency type you should use if you are from geology or if you are from civil. Okay. Now the most important point in this discussion, everything is important, but the most important is you have to determine where to survey. Okay, so this is interesting. Listen to me. Where you can do GPR survey, which study site you should consider. So first one, you have to keep in mind that I have mentioned that the topsoil or the overburden should be resistive. and dry. Okay, so it shouldn't be saturated with water. What will happen if it's saturated with water? The signal will not penetrate that layer. The most of the signal will be attenuated in this layer. Okay, so that what will happen? You will not have the information below of this layer. Okay, so first condition criteria is it should be resistive and dry soil. Okay, second criteria is that water does not GPR do not work in fine grained soil. GPR worked in coarse grained soil. So if you top cover, if you are seeing that it's kind of coarse grained, then you should go for GPR survey. And if you see that the top layer, this top layer is made up of clay, then you should avoid it. Okay, why GPR has a dielectric constant or epsilon r around 81 or 80? Okay, so it is a game changer for GPR investigation. At below, if you were mapping water table, suppose, and the water table at a depth of, this is the saturated zone, okay, and this is the unsaturated zone. So this water table will be mapped more prominently by GPR because the upper layer, suppose I'm considering this layer is dry, obviously unsaturated, and this layer this is a coarse grained coarse sand. Okay, so in this criteria, this is ideal to identify the GPR water table location. How? Because there is a huge dielectric contrast between two layers, and as this topsoil is resistive enough, so you should go for GPR survey here. Okay, so that's the basic site conditions for GPR survey. You should avoid the fine grained. Remember one golden rule, that fine grained sediments are not considered. You will be not considering if the soil cover is fine grained. GPR works well in where? Hard rock also. Okay, the reason will be discussed in another video. So a detailed video regarding this will be coming soon. Okay, so we can say the ground penetrating radar is most useful in low electrical loss materials. And one more thing, what do I mean by that? Low electrical loss materials means the conductivity is low. You know conductivity. So suppose there is a I'm considering a condition where the saltwater intrusion is happening. So this side you have the saltwater. Okay, so what will happen here? If you do a GPR survey here, and if you see the radagrams, then you will be seeing that this side the features will be identified, and this side you will have almost nil signal or zero signal, because the conductivity of the seawater is around 4000 millisiemens per meter, if I am not wrong. So the conductivity is high for the salt water or the sea water, and there you will not having, from this zone you won't have any signal. From this zone you will have the signal, but from this zone you will not having any signal. So it works well in the low electrical loss material. What will happen if the upper layer is salt water or the sea water? What will happen? Almost all the signal will be dispersed, okay, and all the signal will be attenuated. So there will be no reflection back from the surface, no information will be happening. So you will be avoiding if the top layer is saturated with seawater. It does not work if the top layer is saturated of any kind of water. Okay, if it's a seawater, then you should avoid it. But if there is a freshwater and seawater interaction zone, that can be identified in the radargram. So this is our radargram. So here you can easily identify the freshwater and seawater boundary. Okay, so that's the fourth important point you should know before starting a GPR survey. Okay. In case you want to purchase some GPR equipment, which company, which thing you should follow. So there are a lot of service providers are there, a lot of company manufacturers are there. So I generally use, or I generally prefer GSSI. I generally prefer GSSI. I'll put the website in the description below, so you can purchase it from here there. Or Mala GPR is also one good one. It's a good one for GPR equipment. Another manufacturing company is ITS Georadar. Nowadays you might have some airborne GPR system, and this is quite fascinating. I didn't work in a airborne system, but I would like to work in a airborne GPR system. So these are few companies, others are there. Just try to Google it and you will get the result. Okay. So without reading books, you cannot comprehend the total knowledge. So books are must, and which book you should read as for beginners, we will be starting with these two books. First one is the H.M. Joel, my personal favorite, okay, and second one is by L.B. Conyers. So this book is for related to some archaeological investigation and all, but there is some theories discussed in this book is very good enough for the beginners. But I'll suggest go with this H.M. Joel's book. It will be your first priority to read this H.M. Joel books. They have segregated several chapters. They have written several chapters depending on several applications. So you will be reading book edited by H.M. Joel. Okay. So I'll put a photograph here so that you can understand. So these two books will be very important for you. So I'm planning to do a detailed discussion video on GPR principles. So I know the principles I have discussed is kind of very concise. I have discussed in a very concise manner, but there will be a detailed discussion video. If you want it, then write in the comment box below that you want the detailed discussions video on GPR principle or any topic related to GPR. I make GPR videos on every week. So do like and subscribe to my channel. Okay, thank you.